Hello, thank you for watching this video. So in this video, I'll be doing question 7 of November 2022 question paper mathematics paper 2. So this is the 3D applications of trigonometry. So I'm going to read the statement and then answer the questions that follow. AB is a vertical flagpole that is square root 5p meters long. AB is a vertical flagpole that is square root 5p meters long. So AB is a flagpole which has this length here. AC and DC are two cables anchoring the flagpole. So AC and DC are two cables that are holding this, that are anchoring this flag so that it can stay like this, can remain this orientation without falling or moving around. So these are the anchors, this side and that side. So they are more like anchor cable. What is it? Cables that are anchored. They are anchors to that flagpole so that it doesn't shift or move around or whatever. So I would assume that this flagpole is stable now. So B, C, and D are on the same horizontal plane. So B, C, and D are on the same horizontal plane. So these guys are horizontal, which is they're on the horizontal surface. B, C, and D. So B, C, and D are on the same plane, and then up there. So it's more like we have B, we have B, we have C, we have D, and then there B we have this pole here, and then it has these anchors that are fixing it at D and C. So BD is 2 meters. So BD is 2p meters. This is 2p. So BD is 2p meters, right? The angle C, which is this angle of ACD, is x. So this angle runs from the horizontal BD to that anchor, cable AC, and the angle D of ADC is 45 degrees. So this angle runs from the horizontal between C and D to the cable, to the anchoring cable AD. So yeah. So this is the base, this one. And then these ones have their own plane now to think. Yeah. So determine the length of AD in terms of P. They want us to find the length of what? Of AD in terms of P. So if you look, so to deal with this, you must look at this separately. You want to find AD, so this guy here, right? So if you're looking at this, look at this triangle, this one, and that one. You'll quickly discover that we have a right angle triangle. Let me show you. So if you're looking at ABD, you'll see that you have A, B, and D. So this is a right angle here. So you have square root 5p here, right? You have 2p here. So this is A, B, D. So they want this side here. So you use Pythagoras to get that. So you say, okay, I want AD in terms of P. So AD squared, which is this side squared, is called AB squared plus BD squared. So AD squared is equal to AB squared, which is what? Root 5p all squared plus BD, which is 2p squared. So what do you have? You have 5p squared plus 4p squared, right? So AD squared is equal to this, which is 9p squared. Then take the square root, take the square root. So AD is equal to 3p. So you find that your AD, this guy here, is equal to 3p, which is the side here. That's what you have. AD is equal to 3p. Done with 7.1. Go to 7.2. So, what are they saying? They are saying, show that CD is this thing. So they wanted to show that CD is equal to 3p times sin x plus cos x all over root 2 sin x. This is what they want you to show. They want you to show that this length here is equal to this thing here. So you are looking at this triangle. So you must know which triangle to look at. So now, if you're looking at this, you must know that you're looking at this triangle here, this outer triangle here, this surface, this plane here, which is this triangle that looks like this. Because this is the most tricky part. If you know what triangle you're working with. So you have your A, you have your C, you have your D. You have this is 45, right? You have this is X. We have this length here is 3p, is what you just calculated. So they want you to find this small a, this is a small d, and this is a small c. They want you to find this. So you have two angles in one side, right? So you're going to use the sine rule. So you're going to say, okay, I want this guy here. What is it? It's a, right? So it's a over sine angle A. What do I have? It's equal to C over sine angle C. So, what is your A? Your A is A. Is A over sine A. What is your sine A? Sine A, this is an angle here. So this angle here is 180 minus 45 minus x. So it's 180 minus that. So sine over sine that angle, which is sine that 180 minus 45 minus 45 plus x, if you put them in the bracket. Minus 45 plus x is equal to what? It is equal to c. What is your c? Your c is 3p. 3p over sine c, which is x, right? What do we do? 1a, so, oh shit, should have sine here. Sine this thing. So a is equal to 3p sine 180 minus 45 plus x all over sine x. Right? So what do? We say, okay, 3p, 180 minus which quadrant? Second quadrant, right? So 180 minus theta, it's on the second quadrant. What sign is theta there? It's positive. Sine. What sign is this function? It's positive. So you're left with sine 45 plus x all over sine x. So this is a compound angle identity. So you can say A is equal to 3p times sine 45 cos x plus sine x cos 45 all over sine x. A is equal to 3p 1 over root 2 cos x plus sine x 1 over root 2 all over sine x. take out the common factor, so you have A is equal to 3p over root 2 times cos x plus sin x all over sin x. So A, which is equal to CD, is equal to 3p times cos x plus sin x all over root 2 sin x. So you have this. Finished it. Done. Go to 7.3. So 7.3 read as follows. It is further given that P is equal to 10 and X is equal to 110 degrees. Calculate the area of triangle ADC. So it is given that that P, so 7.3, it is given that P is equal to 10 units and X is equal to 110 degrees. So they want you to calculate the area of this triangle ADC, right? So now, so if you draw this triangle separately, let's draw it here. So if you draw this triangle separately here, say okay, it looks like this, right? So you have your A, you have a D, you have a C. So you're given that this is 45 degrees. Now you're told that this is 110 degrees. So you have 3P there, which is there. So it's 3P, which is 3 times 10, because P is equal to 10 now. So you have 30 here. Here, CD, you've said you can calculate CD like this. So let's go and find the value of CD. So CD is equal to what? CD is equal to 3P. 3 times 10 sine 110 plus cos 110 all over root 2 cos root 2, which is this, sine 110. So this will be your length of CD. So let's find the length of CD. Punch this in a calculator. 3 times 10 times sine 110 plus cos 110 all over root 2 times sine 110. So what you have that CD is equal to 13.49 units. So this is this here, 13.49 units. So now if you want the area of your triangle, this one, it's going to be half this side times this side, sine of the angle between them. So it's going to be area of triangle ADC. It's called half AD times CD times sine angle D. So it's going to be 1 over 2 times AD, which is 30, times 13.49 sine 45. So this is equal to half of 30 times answer times sine 45 degrees. This is the area of triangle ADC. It's equal to 143.11. So here's your area. So we're done with trigonometry.